Welcome to Study Loop.
This is the answer to Chapter 13, problem number 45 from the Smith Organic Chemistry textbook. And in this problem, we are given a bunch of information about a chiral hydrocarbon called X. We're told that it has a molecular ion at 82. And then we're given 3 pieces of IR data for this molecule. And we're asked to propose a structure for this molecule X. And so I'm going to take each of these pieces of information one at a time and use them to build the structure that we're looking for. So first, we're told that this is a chiral hydrocarbon. And so this is actually quite a bit of information. So we know that there are only carbons and hydrogens in this molecule. And we know that one of these carbons is going to have 4 different bonds because that's where chirality arises from. So that's good information. So next we can move to the molecular ion peak at 82. And we can start to think about how that's going to play out. So we know that we have just carbons and hydrogens. So if we, let's say, had 6 carbons, so that would be C6. That's going to account for 72 of our 82 M to Z. And so we would then have 10 hydrogens. And so that's going to get us to 82. That's a formula that seems to make sense. We can go ahead and calculate an HDI for that formula. And so that's going to be 2 times 6 plus 2 minus 10 all over 2. So 12, 14 minus 10 is 4 over 2 is 2. So, okay, so we have 2 pi bonds or 2 rings or a ring and a pi bond. And so that's good. That's good information. And so next we need to look at the IR information that we've been given. And that should help us finally pin down exactly what's going on with this molecule. So we have a peak at 3,300 wave number. And so that is going to correspond to a CSP hybridized carbon bound to a hydrogen. Okay, so it looks like we have a triple bond, and we do have 2 degrees of unsaturation, and a triple bond would fulfill that structural requirement nicely. And so then we have this 3,000 to 2,850, and hopefully by now everyone has committed to memory for the rest of your life that's going to be a CSP3 hybridized carbon bound to a hydrogen. So they are pretty much ubiquitous in almost every molecule. We're always going to see that. So that doesn't tell us too much. We already knew we had a hydrocarbon. And then this peak at 2250 is going to be the actual carbon-carbon triple bond peak. So just further confirming that we have a carbon-carbon triple bond. Okay, so we have all the information that we need now. So we have 6 carbons. 2 of them are triple bound together. And we know that this molecule has a chiral center. So how can we put all of that together? Well, so let's start with the chiral center. So there's a chiral carbon. Let's put a hydrogen on it. Okay. And then let's put our triple bond on it as well. Okay. So right now we've fulfilled all of our IR data. And then we need to account for 3 more carbons. So let's make one a methyl group. And then let's put an ethyl group over here. CH2. Okay, so let's count. 1, 2, 3, 4, 5, 6. 3, 5, 6, 9, 10. So this fulfills our C6H10 formula. We have our 2 degrees of unsaturation in the triple bond. We meet all the criteria that the IR gave us. and this is indeed a chiral hydrocarbon. And so this doesn't have to be the only answer. There's another, other ways to draw this. There's an enantiomer, but this is certainly a good answer. Yeah, so I guess the only other answer would be the enantiomer. So something like this. Yeah. Okay. So that would work too. Yeah. And so that's the answer here. And that's the way to approach this problem. We just need to realize that we're given lots of information and how to use that information. Um, and again, I would always start with the M to Z, figure out a formula, get the HDI for that formula, and then look at spectral information and see what you can piece together from that. And then use that to assemble the molecule. And that's the answer to chapter 13, problem number 45.